Hi, George Crump with VergeIO. Today we're going to talk about how I/O and storage works within the VergeIO infrastructure. In our last video, we built out a four-node environment. We talked about the integration of VergeFS, VergeHV, and VergeFabric into a single code base that we call VergeOS. Today we're going to look at how that interacts with data, because obviously us managing storage is an important aspect here. So when a new piece of data comes into the environment, uh, it'll be assigned to one of the nodes that's contributing storage, and then that node is going to segment that data into chunks. And what we're doing is we're looking for some redundancy within that chunk, basically deduplication. And so as we do that, we're going to go through and say, okay, I've seen this chunk of data, I've seen that chunk of data, I've seen this chunk of data, and I've seen that chunk of data. Now, what's important, because our deduplication is integrated here at the hypervisor level, once I've identified these redundant chunks, I'm done with them. They're not going to go across and hit other storage systems. They're not going to be processed by other processors. We just update metadata and we're done. Okay. Now, for the new data, which would be represented by these two segments right here, what I'm going to do is write them to two different nodes and two different drives. And so essentially what that'll look like is I might write the primary of this unique segment here and the primary of this this unique segment here. And then I'll write my secondary copy, maybe of this one over here, and maybe of this one over here, right? And so what I've got now is a nice distribution of data that gives a couple things for me. This is one of the areas that we see a performance improvement in storage. Another area is this integration that I mentioned earlier, and we talked about in the last video. Because storage isn't running as a VM, it's running as an equal citizen of the hypervisor, it tends to perform better. The second is this distribution of data across the different nodes in the environment. Now, the second thing that sets me up is for very, very good high availability and data protection. So if I have a VM running here, over the course of time, its data will probably hit almost every drive that's contributing storage or in the environment. If this VM is running and say this drive fails, it knows where the partner drive is for that piece of data, or the partner segment actually, and what drive it's on, and it'll return that data directly to that VM. So there's no algorithmic restore that has to happen here. So as a result, there's no performance loss or degradation in the event of a drive failure. Now, we've got the drive failure situation covered. The second is, okay, what happens if a server goes down? Server typically goes down for one of two reasons. Number one, you might put it into maintenance mode because you need to do a memory upgrade, or you need to do swap out a NIC, or whatever might happen. Well, when that happens, what you do is you tell us to put, say, this server into maintenance mode. And before we do anything, though, we'll live migrate the VMs from that node to the other nodes in the environment. While we're doing that, we'll also auto load balance those VMs, so we make sure that we don't overwhelm a particular node or server in the environment. We'll correctly place everything so we maximize the remaining amount of performance. If a server crashes and it goes down suddenly, what we'll do is we'll restart those VMs on the surviving nodes. Again, auto load balancing to make sure we don't hit anything. So in the first example, there's no downtime whatsoever. Everything happens live. It's sort of our equivalent to vMotion. In the second example, there's only enough downtime for there to be to restart the VM. So 20, 30 seconds, whatever it takes to boot a particular VM is all that takes. So we've got the core essence of both high availability and drive failure protection built into the product. And we'll talk about in future whiteboard sessions how we can take that even further with our IO Guardian capability. For now, though, I'm George Crump. Thanks for watching.